Example 8. Find the volume of excavation required for the area shown in figure 4. The figure at each grid intersection represents the depth of cut at that location. Depths in parentheses represent meters. So here we have a large excavation, 121.9 meters by 91.4 meters. So the first step in calculating for the volume of excavation is to divide the area into grids. So here we have grids in the x-axis. So it's being divided into 4, and then the area is also being divided into 3 in its y-axis. So through the use of survey instruments, different elevations are recorded at each of the intersections of the grid. And we will use these values here to solve for the volume. And we know that volume is simply equal to area times height. But what is our height, or the average depth of excavation? We will use this method, which I'm going to illustrate now, in order to find the average height. First, let's classify all the points. We have corner points here and here, and we have border points. Okay, border points, and we have interior points. Alright, so let's try to tabulate the data. So for the corner, let's say 1.83 meters starting here, then 1.04, then 0.61, then 1.22. Okay, so there are only 4 corner points. Then we have border points. Let's start here, 1.77, 1.59, 1.4, we have 0.92, then 0.85, then 0.92, oops, then 1.07, 1.46, 1.46, then 1.68. Then we will have our interior points. Let's start here and go counterclockwise. We have 1.52, 1.40, then 1.28, then 1.1, then 1.22, and lastly 1.49. Okay, so how many intersections do we have? We have 4, or rather 5 by 1, 2, 3, 4. 5 by 4. So there are 20 points. So let's see if we have 20 points here. So the count here is 20. So we have recorded all the points. Let's say this is the depth. And now we introduce this, what we call the weight. If the point is a corner point, the weight would only be 1. Okay? And if it is a border point, the weight will be 2. Okay? And if it is an interior point, the weight will be 4. Okay? So let's try to multiply the depth by each of the weights. So here we have depth times the weight. Then let me copy this one. And let me copy this one. Alright, so we now have the values multiplied to the weight, the depth multiplied to the weight, and let us try to have a summation of all of these values here. So summation, let's sum up everything here. We have 62.98, and we also sum up all of the weights here. We have 48. Okay, so the total weight, the total of sum of the weights is 48, and the total depths multiplied to each of the weight is 62.98. So to get the average depth is simply dividing this sum by this average, or the sum of weights rather. So average depth is equal to this value here divided by 48. So that will be 1.312. Okay, so the volume now is, or let me calculate the area first. We have the x dimension, we have 1 to 1.9, and the y dimension we have 91.4. So the area will simply be equal to x times y, or 121.9 times 91.4. So that will be 111, or 11,141.66. So the volume now will be the area times the average depth. So area here multiplied by the average depth, and that is equal to 14,618.79 cubic meters. Thank you very much.